Let's move to our first board where we are going to talk about DR and BDR election process. Okay. So what is the aim here? The aim here is that if you consider this diagram here where we have one switch and the switch is connected to 5 different routers, right? And the whole sole point was that once we reach to two-way state, I am again saying once we reach to two-way state, and what is the meaning of two-way state is that R1, if we talk about R1 and R2, whenever we are running OSPF on all of these routers, the first thing they are going to do is they are going to generate hello message, right? When they send this hello message out of this interface, this hello message is going to be received via this router, right? Once it is received on this router R2, it is going to understand that there is somebody with the router ID R1 and which speaks OSPF, and then basically it replies back and it makes sure that R2 included the R1 router ID in its hello. Once this reached to R1, R1 is pretty sure about it that, okay, there is somebody with the name router R2 or router ID R2 and he has seen me. Why? Because the hello from R2 contains my own router ID, right? So this is the two-way state. R1 is going to reach to two-way state. Similarly, if we talk about R3, R4, and R5, they are also going to introduce the hello packet as soon as you configure OSPF on that. And at the end of the result, every router basically here on the LAN segment, it is going to be two-way state. And R1 should understand that basically there are 4 more routers on this LAN interface. It is as simple as that. So according to R1, there are going to be R2, R3, R4, and R5. These are the neighbors. Neighbors of whom? Neighbors of R1. It is as simple as that. Similarly, if I talk about R2, R2 come to know once it gets the hello from all the routers, it is going to understand that there are R1, R3, R4, and R5. These are the routers which are attached to the same link, right? And everybody is in the two-way state, but two-way state is not something where you can start sharing the routing information or LSAs, right? Because at the end of the day, what we are doing here is we are moving from neighborship towards adjacency, right? And once we make the adjacency, then we share routing information over the adjacency. So everybody in this topology understand that there are 4 more routers apart from me, which are my neighbors, right? But as you all know, we are making neighbors here because we want to share the link state advertisement or link state information to everybody. And to reduce that flooding, we generally choose a router, which is a DR router, and a BDR router, which is the backup of this DR. And just try to understand from left-hand side, we are going to move towards right-hand side, where out of these 5 routers, we are going to select 2 special routers, which are DR and BDR, and try to understand the remaining routers are going to make adjacency with them. What is the meaning of adjacency? The meaning is they will move away, they will move forward from two-way to adjacency, right? Because you understand that two-way is not the state where we are going to share the routing information, but yes, we need to move forward if we want to send routing information. And although there are multiple states between two-way to adjacency, but you can understand that we have selected DR so that all DR other routers. So basically, a router which is on a LAN segment which is not a DR or which is not a BDR comes into this category of DR others, right? Because these are not DRs and not BDRs. It is as simple as that, right? So if you consider the DR others and DR, what is happening? DR others are going to make adjacency uh, with DR and BDR. It is as simple as that. So what you are seeing as in orange color here, these are the adjacency guys, right? And over this adjacency, you are sharing your routing information or LSs. It is as simple as that, right? So how the election means how we come to know that Mr. R5 and Mr. R4 are going to be the DR and the BDR, and that is the gist of this complete board, right? As I mentioned, this protocol uh, was developed in 1980s, right? Pretty old protocol, and that is why I think we have two RFCs, and that is why we see some difference in behavior when we see this protocol running actually on the routers, right? I will tell you some of the differences. So, but right now, just try to understand that this protocol has been built in 1980, and from there, we are following this process of DR and BDR election, right? But to give you an idea, how an hello packet look, and you have all seen this packet in the actual Wireshark, maybe I think 3 or 4 lectures back. So I think you remember that. If you do not, then it is perfectly fine. The whole sole agenda is that we have to identify a designated router, which is DR, and backup designated router, which is BDR. It is as simple as that. So if I look into this hello message, right? You all know that whole hello is generated by OSPF protocol, and OSPF protocol works at layer 3 or the network layer, right? And this OSPF messages are going to be encapsulated in IP, then it is going to be encapsulated in Ethernet and then sent away. And that is what you are seeing here. We have OSPF protocol, right? Which is encapsulated in IP, which you can see here. The source of this is something from the second router 192.168.123.2, and the destination is 224.0.0.5. You understand all these things, and then basically IP protocol is encapsulated in Ethernet. You can see the source IP and the destination IP address is the multicast MAC address. Sorry. Okay. So the destination MAC address in Ethernet is the multicast MAC address. It is as simple as that. But if we go inside and check some of the things of the OSPF hello packet which are relevant to this board are this one, which is router priority, right? Designated router and backup designated router. So try to understand when everybody comes up on this link, right? They do not have any clue about who is DR and who is BDR. So irrespective of the fact who has generated this hello, maybe this hello was generated by R5, R4, R3, anybody, right? But they do not have any idea about where the designated router or where the backup designated router is. If I am starting from the scratch, all the routers are new, freshly booted, nobody has any idea who is DR and who is the BDR, and that is why any router which is going to create the hello, it will include 0.0.0.0 in its designated router field. It is as simple as that, right? Of course, in the backup designated router field, it is going to say 0.0.0.0, which signifies or which specify that this router doesn't have any clue about its DR and BDR, right? It is as simple as that. The another criteria is it is specifying the router priority. So this priority value can be from 1 to 255. What is the meaning of it? Actually, this value couldn't be configured on this interface. So maybe this value can be between anything between 1 to 255, but the default value of this priority is 1, right? So you can understand the priority of this interface is 1, priority of this interface is also 1, the priority of this interface is 1, here we have 1, here we have 1, right? So what OSPF says that if you want to take part in OSPF, then you should have some priority value, right? And we all can see that because OSPF default nature is that it is going to put router priority value 1 on all the router interfaces. It means that all the routers by default on broadcast network are eligible to take part in DR BDR election, and that is why all the routers here R1, R2, R3, R4 and R5 are completely eligible for DR BDR election. They can take part in DR BDR election. But if you do not want a particular router to take part in this election process, then what you can do is you can specifically mark or you can specifically configure the priority value at 0. 0 means this router is not going to take part in DR BDR election process, and that is why the default value is 1. Higher this value means if you have consider the chance that maybe R2 has this value, R1 has this value 100, and R2 has this value 200, suppose. So there are more chances if we need to select a DR out of these two, then basically the one which is having the highest priority is going to win the election, right? The first thing in the matching criteria is the priority. The second thing is if priority is same, because it is going to be same. If you haven't configured it, everybody is going to have the priority value as 1. And if that value is 1, then you can understand that if priority is tie between two routers, then we need to select the DR or the BDR on the basis of some other parameter, and that other parameter is router ID. So I will take an example from my lab itself. I have configured on R1 1.1.1.1, which is the loopback interface. And you also know that the highest IP address of the loopback interface, if you do not define router ID, then it is going to be your router ID, right? Similarly, if you have R2 and you have defined 2.2.2.2 loopback interface, and I have defined all these loopback on my lab, so you can understand that the highest router IP is going to be R5, right? Which is 5.5.5.5. It means that the priority is 1, but the highest the router ID is going to be highest for these guys, right? So actually what happens, everybody is sending hellos with all these parameters. If we talk about router R1, right? R1 knows that it has neighbors. What are its neighbors? The neighbors are R2, R3, R4 and R5. Everybody is going to send the hello messages, right? And inside this hello messages, everybody is writing that nobody knows who is the designated router, who is the backup designated router. So how does R1 come to know about who is the DR, right? So it start the process of DR BDR election out of these, and it start looking into the hello message from every other neighbor. Means it starts looking in hello message of R2, R3 and R4. First thing first, it is going to see the priority value, which is absolutely 1, because this is the default value which comes with the OSPF, right? Then it is going to see the next tiebreaker, which is going to be your router ID, and router ID is highest on router number R5. It is as simple as that. So R5, basically they are going to elect. But what they are going to elect, because most of the people asked me that this process have been asked in many interviews, and what is the first thing which we are going to, what is the first thing which is going to elect, whether it is going to elect DR or it is going to elect BDR. So it is going to elect BDR first, and the reason is OSPF have generally in the current implementation of OSPF, OSPF has only one election process. It is always going to elect the BDR. It doesn't elect DR, right? So this is the implementation. There is no specific why they have chosen it. I am again referring to the fact that this protocol is developed in 1980s. They want to make it really simple. So they have only one election. They are just every time there is a DR BDR election, actually the election is happening for the BDR, right? So right now, as you see, R5 is the topmost router ID. It means that it is going to be the BDR because OSPF selects only the BDR, right? But as soon as it sees that, of course, that out of the all the routers, it is selected the BDR. It is just changes state from BDR to DR because this is the very first router out of these which got elected as the BDR. Means R5 was elected as the BDR, right? But there is nobody on this network which is a DR. So what OSPF algorithm does, it will move it from BDR to DR, right? And then, as I mentioned, it can only elect a BDR. In the second step, it is again start moving to find BDR again. And of course, this time R5 has become the DR because OSPF has OSPF has changed its state from the BDR to DR. It is going to find out BDR from the next or the remaining router's hellos. And of course, R4 is going to have the highest router ID, then it will become the BDR. So with the one algorithm only, you can calculate DR and BDR. But OSPF in current implementation, they always try to find the BDR, right? And that is what happening here. The first thing when they find the highest IP address, they found the R5, but there was no DR elected on this link, on the Ethernet link, and that is why they have promoted this BDR now they have promoted the R5 from BDR position to DR position, and then they start finding the BDR again. Maybe it is little bit of confusion, but that is fine. Actually, there is no why behind it because there is the implementation. There is the implementation which is happening in the current OSPF version. So I'm repeating once again for your clarity that OSPF has only one algorithm through which it is only going to select BDR, right? And when it selects the BDR, which is router number 5, and it sees that there is no DR, it is going to promote it from BDR to DR. And now there is no BDR, and that is why it is going to select the BDR now in the next election process. But the election process is always going to be happening for backup designated router and not designated router, right? It is as simple as that. So if I talk about it, then R5 is going to become your DR and R4 is going to become your BDR, and all other routers which are not DR or BDR, they are going to be DR others. Do not worry guys, I will give you ample amount of time asking questions. Just write down your questions, just concentrate on the board, this one and the next one, and then I will come back for the questions, right? So this is exactly how the DR and BDR election work, right? So once we have find out that R5 is the DR right here, right? And R1, R2, and R3 are the are the DR others, means they doesn't fit into the category of DR or BDR, so they are DR others. Then they move from two-way states, and then there are some middle state, and then they basically form the adjacency. And over this adjacencies, they are going to send LSAs. It is as simple as that, right? So if I talk about the point-to-point links, right? And that is what I wanted to discuss with you. Suppose we have R1, we have R2, and suppose there is a point-to-point link between them, and we are running point-to-point protocol, right? Or it is going to confuse you. Suppose we are running HDLC here, which is another point-to-point protocol, right? We have R1, we have R2, we are running OSPF here, right? Then now just try to think from the perspective that why we are electing a DR or BDR. The whole sole purpose was that if we have a switch, and if this switch is connected to more than one router, maybe 3 or 4, we do not want excessive flooding with respect to LSAs on this network, and that is why what we are doing, we are selecting a DR here, and everybody else is just sending the LSAs to DR, and DR is eventually sending back them to all DR others routers, right? It is as simple as that. Why we are doing this? To reduce the flooding of these LSAs. Now just try to understand, do we need a DR and BDR on the point-to-point link? Just try to think. No, absolutely not. And the reason is that R1 knows that this is the point-to-point link, right? And I can expect on this point-to-point link only and only one neighbor, right? Which could be anybody, but point-to-point means, the technology itself means that I will not be having more than one neighbor, right? I won't be having more than one router at the other end, because this is the point-to-point link. And if this is the point-to-point link, then basically it doesn't require uh, this this kind of election process, because always whatever is going to be my neighbor, I have to exchange LSAs with it, right? And the reason is because R2 should know about R1, whatever the LSA is here, and R1 should know whatever the LSA is of R2, and that is why I say R1 and R2 are neighbor as well as adjacent router, right? Because they are exchanging LSA. But here you do not need an improvement, just like the Ethernet, right? Why you do not need because on the Ethernet, there are chances that you are going to have excessive flooding with respect to LSA, because every router is sending LSA to every router if you do not elect DR. But here, there is only two routers, so there is no concept, there shouldn't be any concept of DR, BDR here. And that is why if you see on the point-to-point links, there is no DR and BDR. But you should understand the why behind it, because there is no need of it, right? And that is why there is no DR and BDR. So people ask me most of the time, and I would say, please give me 4 or 5 minutes of your attention, because this is very important topic which I am saying, right? Although if you can see the point-to-point link in the WAN, right? Which are the leased line also. But try to understand that when we developed our LAN side also, okay, and suppose we have three routers here. We have R1, we have R2, and suppose we have R3, right? These are connected in this manner. R1 is connected to R2, R2 is connected to R3. It is as simple as that, right? But here on the LAN side, we do not have point-to-point link. This is not working in HDLC protocol, right? This is a simple Ethernet. This is also the simple Ethernet. Although Ethernet medium or the broadcast medium is capable of connecting more hosts, you can straight away connect a switch here, and you can straight away connect a router or many routers here, right? But most of the times when we use even Ethernet on the LAN side also, we see that there are only two routers, R1 and R2. I take a cable, Ethernet cable, put into the RJ45 connector of R1 and put the same Ethernet cable at the other end. So this is going to connect my R1 to R2. But try to understand, although this is the Ethernet medium, but actually if I am designing this network, I can be pretty sure that on this on the other side of this Ethernet cable, there is going to be only one router, because I have configured this. Similarly, between R2 and R3, there is a link, and R2 and R3 is behaving just like this point-to-point, right? And in this point-to-point, the above figure, we understand that there is no DR BDR required, because there are only two routers, right? So try to understand here, if we are running Ethernet, if we are running OSPF on all these routers, what is the default behavior of OSPF? OSPF default behavior is, it is just going to see what is the network interface attached. When it sees is the Ethernet interface. It is going to run its broadcast network type here. Guys, we have discussed the network types of OSPF and we have discussed only two, point to point and basically broadcast. In case of point-to-point like HDLC, there is no doubt that OSPF is going to run point-to-point here and point-to-point network type here, right? Because it's the point-to-point link and there is only one router at the other end. And if OSPF is running point-to-point, OSPF understands that I am running point-to-point because it is a point-to-point link. There is no need of selecting DR and BDR. But try to understand what the point here is. On this link is the Ethernet link, and by default OSPF run broadcast network type on this Ethernet link, right? And if it does so, then basically on the broadcast medium it needs to elect DR and BDR because it doesn't know how many routers are going to be here in the future. Maybe right now two, but there might be three. So it is running broadcast. But try to understand, this is the default behavior. What we are doing here is we are increasing the efficiency, right? Just try to understand how did we increase the efficiency in the broadcast medium by selecting the DR BDR. But here we do not have any other router on this link. We have only two routers, right? Because although it is an Ethernet link, but it is behaving like a point-to-point, right? Because you are the designer of this network, you know that over this wire I will connect only two routers. So doesn't it make sense? Just try to understand. It is going to make sense if you change the default behavior of OSPF here and convert this from broadcast to point to point. And if you do that, then basically you do not need to elect a DR and BDR because on point-to-point network type, OSPF is not going to elect DR and BDR. But if you choose the default behavior, which is broadcast, although you are going to have two routers, you are still going to need to select DR and BDR because this is the OSPF by default behavior that on the broadcast network type, it is going to elect. So although you have only two routers, your routers will be busy in selecting DR BDR. And why to make them busy if you know that there is a link which is only going to be connected with these two routers and nothing else. It is as simple as that, right? So do not get confused. I am just saying that if you are building your own network, right? And if you know that over this Ethernet link, basically only two routers are going to be connected, but OSPF default behavior is it is going to run broadcast network type and it is going to elect DR and BDR. But you know that DR and BDR shouldn't be happening here because there are only two routers, then you can change the default behavior just for the efficiency sake, right? But most of the people doesn't understand the nitty-gritties of OSPF and then they let the things work within the default mode. I'm not saying this is the wrong approach. This is going to work. But if you're a designer, efficient designer, you can look into it and change the broadcast mode from a broadcast to point to point. Having